1.3 is about measuring segments. There's two sections in this chapter, this first chapter, that are really going to lay the foundation for everything that we do in the entire text and everything we do in the entire realm of geometry. And it's measuring distances and measuring angles. If we can do those two things, then all of the other measurements, all the other calculations that we do in geometry are based off of those two concepts. So if we get a really good understanding of how to do this, then it's not going to be a very hard stretch to then start doing those types of things inside triangles, doing those things inside circles and rectangles and that kind of stuff. And we've already talked about how we identify segments and symbols and stuff like that. The first thing I want to talk about is that when we measure something, that thing we measure has to be finite. Okay? Finite means it has to have a beginning and an end. Does that make sense? Okay. If I asked you to count all the blades of grass in the courtyard, that would take you a long time, but it's doable because the number of blades out there are finite. You can attach a number to each one of them. Does that make sense? Okay. If I asked you to find the length of a line, you cannot do that because lines go on forever in both directions, right? So there's nowhere I can put maybe my tape measure on one end and pull my tape measure across to the other because they don't start or stop. Does that make sense? Okay. So the only things that we can measure are segments. Okay. Lines and rays do not do that. A ray does have an endpoint. When I put my tape measure on that endpoint and then I start rolling my tape measure out, because that ray goes on forever, I'm never going to be able to stop, right? So I'll never be able to get a distance of that thing. Okay. So lines and rays do not have distances, but segments do. Okay. Here it says on a number line, every point is paired with a number, and every number is paired with a point. That's what we call a one-to-one correspondence. Okay. Every number has a point. Every point has a number. Okay. And that setup essentially allows for us to measure distance. Okay. If I want to measure the length of something, just notation-wise, and this is what this is saying down here in the bottom, if I say M, and this is something we're just going to have to get accustomed to, get used to. If I say MV and I put that there, okay, I am talking about a shape. I'm talking about segment MV, okay, and there is no number or anything like that that should be attached to that. It's a segment. It's an image. Okay, it's a shape. Okay. If I want to start talking about characteristics of segment MV, and the main characteristic is its length, then I do it this way. I write MV, and I do not put a segment over the top of it. So if I see two capital letters stuck together like this with no segment on top of it, I read that as distance or length MV. Okay? And in this case, that distance or length would be 4, right? Okay, everybody? Okay. Now, I think, especially, this is why I put this example, obviously it's not hard, but if I wanted to determine the length of this, a lot of people might go, well, that's 1, that's 2, that's 3, that's 4, right? Okay. And that's a perfectly fine way of measuring distances if they're relatively short or small. And if my number line is, if the intervals are broken up consistently in the same manner, okay? So there from every single hash mark you see up there is one integer, right? -2 to -1, that distance is the same as -1 to 0, which is the same as 0 to 1, which is the same as 1 to 2. Because it's broken up that way, I can do that counting process to get my distance. Now, counting, much like when you guys did rise over run last year, you did slope, counting is a shortcut, but it never, or I won't say never, doesn't always work out for us, okay? Let's say I don't even know what my values are. Let's say that this distance here is, let's put A there, and let's put this value here at B, Okay, so A represents some number. I just don't know what it is. And B represents some number. I don't know what it is. Okay, but if I look at the hash marks between A and B, it's 1, 2, 3, 4 again. Okay, so should I say the distance AB is 4? Even if I don't know what A's number is and what B's number is? I can't do it that way. Okay, so the way that we end up measuring things, okay, is that we take the two coordinates. That's what these values are called, okay, for these points. So B is called a coordinate. We take that value and we subtract from it the value of this one, okay? Now, in most texts you're going to see, they're going to write it as B minus A. They'll put B as the furthest point to the right and A the furthest point to the left. And they're going to go B minus A because, well, a point to the right on a number line is always bigger than a point to the left, right? So that's going to guarantee that my result is positive. And distances have to be positive, okay? But it doesn't matter, okay? Because what we're going to do is we're going to put those things around it, okay? And that's just going to double check. It's going to guarantee that my distance is positive. What do those bars mean? Absolute value, which is just telling me the distance something is from 0, okay? So B minus A, or you'll find out that you can write A minus B, okay? I like to give formulas in my notes, specific formulas, so that when you see them somewhere else, you know, hey, I've seen that before, I know what he's talking about. But I also like to give like a general, generic, you know, this is the way I can do it without a formula type thing. So I always think absolute value, I can go endpoint minus endpoint. And that's more of a general way of, or generic layman's term way of finding the distance between something. Okay. Now, most of you, who has never measured something with a tape measure before? So we've all pretty much measured with a tape measure, right? Okay. So you take the tape measure, you take the little hook, right? And you put that on the edge of whatever you're measuring, and then you take your tape measure out and you line up where your tape measure meets the other end of the object you're measuring, right? And you just read off the distance, correct? Do I have to do it that way? What is that, when I have that hook, what does that hook represent? What number on the number line does that hook represent? 0. And then when I'm on the other side of what I'm measuring on my tape, and maybe it says 48 inches, and 48 is that other endpoint, right? So how long is my object I'm measuring? 48 inches, right? But it's 48 minus 0. Does that make sense? So what if instead of putting my hook on the end, let me draw this so people that are online can see what I'm talking about here. Let's say that I have, let's see here. Bear with me a little bit. I'm missing one of my tools here. I don't know what section it's in, if it's even there. All right. Now I lost my pen. There it is. All right, so let's say that I've got maybe just a piece of drywall that I'm trying to measure, okay? And I take my tape measure, and I put the hook of my tape measure right there, okay? And I span my tape measure out, okay? And right there I would read, like I said, 48 inches, right? This little hook would have been 0 inches. So I know that easily reading my tape measure, I got a 48 inches of drywall there, right? Okay? But I don't have to do that. Let's say, for some reason, my 2 daughters like to get my tools and just play with them, okay? So my 6-year-old has broken every tape measure in my house, okay? So like she'll like pull them out, and then she'll play with this little hook thing, and she'll bend the tape back and forth. So none of them have that hook on them. Okay, so and if I want to measure something, I want to do it accurately. What I have to do is I have to put my tape measure out here. Okay, so got the tape here, but now instead of this reading 0 inches, now it's reading maybe 5 inches. And then over here, this is going to read 53 inches. Does that kind of make sense? Well, how long is it? It's the same piece of drywall that was 48 inches a minute ago, right? Well, how do I get that 48? I go 53 minus 5, right? Take the absolute value, gives me 48 inches again. Does that kind of make sense to everybody? So when you're using a measuring device, whether it's a tape measure, ruler, whatever, number line, and that's all a tape measure is. It's a graduated number line. Okay, you guys know what I mean by I say graduated? It's got markings on it. Okay, you guys talk about graduated cylinders in science class? Yes. Okay. So what's the difference between a cup that I drink out of at home and a graduated cylinder? It's just the lines on it that tell me how much liquid or whatever substance is in that cylinder. Okay, graduated just means it's got measurement marks on it. So our number line is going to allow us to do that measuring. Okay, and we're just going to subtract the two quantities that we see as endpoints. So when I'm up here, obviously, how can I get 4 out of that when I want to find the measurement of or the length of MV? Can I take 2 minus negative 2? What's 2 minus negative 2? 4. Does it matter the order I go? Can I go negative 2 minus 2? What's negative 2 minus 2? Negative 4, but I'm going to take the absolute value because it's going to be a distance, right? Does it still give me positive 4? Yeah, okay. So something I do, and this will be on, this should be on the homework. It's definitely on a quiz. If I give you a number line, okay, I'll give you the option on one of them to be able to count. That's, everybody wants to count and get the answer that way, and that's fine. But I'm going to do something like this. I'll put my marks on here. I'm going to say this is like negative 90. This is negative 80. This is negative 51. This is 0. That's pi. That's 312. And that's 500. Okay? And if I put, let's say, M right there, and I put V right there, can you, now just by looking at my number line, is my number line chronological? Is it in order left to right? Yeah. But you're seeing that based on the values I chose, my intervals, even though they're visually spaced the same, between M and like the negative 90 is only 10 units, right? But if I look at M and the negative 51, that's 29 units, right? Okay. So even though the sizes are the same, those size representations are different. So if I count from M to V, I get 1, 2, 3, 4, right? Is that length from negative 80 to 312 really 4? No. So the way you have to do this, the way you're going to find MV, is that you're going to take 312 minus negative 80, take the absolute value, so it's going to give you what, 392? Does that kind of make sense to everyone? Okay. So you're going to, and that's the, I think counting, guys, is one, it's going to get you in trouble sometimes. Two, it's a lot slower, okay? Subtraction, if we think about it, is a way of counting. It's a quicker process for counting. So let's use that instead, okay? If we have 14 people in here and I kick out 3 of them, okay, and then I ask the people that are left in here, how many people are in here? Are you going to go through and count each person? Or are you going to say, I knew I started with 14, got rid of 3, I got 11. Don't need to count them, right? It's a quicker way of counting them, okay? So if we can use subtraction, please do so. Does that make sense? We good on that? All right. When we measure angles, there will be a very similar process, okay? Most of you are familiar with using a protractor in kind of a traditional way, I will show you how you can use a protractor kind of contrary to what you learned in like maybe the 4th or 5th grade, okay, which through subtraction makes it very easy to use a protractor. We already talked about this, so I'm going to kind of skip it over just to save a little bit of time today, but it is another place where we see postulates and axioms show up as a definition, okay? Remember, postulate is something that you cannot prove, okay? And I asked you to remember them by their content or their statement and not by their name, okay? However, there are some exceptions to that rule in which you can learn them by their name, and that's when they have a specific name. Because the ruler postulate in this geometry textbook is the ruler postulate in any geometry textbook that you would ever pick up. Okay? And basically what it says is it's a technique or a system to generate a measuring device for us. Okay? So what we were just able to do algebraically, the ruler postulate sets that up for us. It tells us that every point on a number line is paired with a number, and every number is paired with a point in such a way that when we subtract the two endpoints, we can get the distance between those 2 points, okay? So every point on a line can be paired with a real number. This makes what we call a one-to-one correspondence between the points on the line and the real numbers. The real number that corresponds to a point is called the coordinate of the point, okay? And then it goes on to say the distance between points A and B is the absolute value of the difference of their coordinates, A minus B, or it could be B minus A. Okay, it doesn't matter the order as long as we take the absolute value. So this value would refer to as distance AB. Okay, so the ruler postulate is what allows us to do the subtraction that we were doing a minute ago in those examples. Okay, is that all right? Every time that we do something in this class, and just mathematics in general, and mathematics that you have done so far up to this class, there has to be an underlying reason of what allows you to do that. This is the underlying reason that allows us to measure things, okay, measure distances. Let's go on to what we call the segment addition postulate. So the segment addition postulate is now saying, and this is convenient because when I want to find a large distance, it might make more sense to break it up into smaller groups and then add those smaller segments together. Does that make sense? Or smaller groups together. Okay. So the segment addition postulate, and then we got to talk about some key structures of this sentence. It says if 3 points A, B, and C are collinear, that has to be true. They have to be collinear. And B is between A and C. So I'm going to highlight these things that are critical. Okay? Because we'll come back and talk about, what if, because I will write this postulate on a test or quiz, and I'll mess it up on purpose and ask you, is it true or false? Okay? So I'll mess with some of those things I highlighted and ask you if it's true or false. Okay? So if 3 points A, B, and C are collinear and B is between A and C, then AB, distance AB, plus distance BC should equal distance AC. Think about that, okay? This if part, okay, and you're going to hear me, and there's actually, I don't know why we don't do this earlier than when it happens, but in Chapter 2, we actually talk about the structure of this statement. All of our statements are going to start with an if, and then about halfway, 2/3 of the way through, there's going to be a then. All of them throughout the entire year, okay? The if part is what we call our condition, and that has to be happening in front of us. I always talk about the if part being like a picture. If I can draw this picture in front of me, then the then part is going to be true, okay? The then part is called the conclusion. We'll investigate the structure of that sentence later on. But we got to have this part that is starting at if and goes all the way up to the word then. If that stuff is not true, then this doesn't even matter, okay? So we got to make sure that this stuff from if all the way up to then is happening. Is that happening over here in this picture? Is A, B, and C collinear? And is B happening between A and C? So it is. So for this situation then, this must be true. You must be able to stand on A. It's my stick figure. If you're standing on A, you can walk to B, and that distance would have been AB, right? You can then, when you're standing on B, start going again and finish at C, right? So if I walk those two distances, AB, and then I followed up by BC, can I determine that I walked a total of AB plus BC when I'm done? That makes sense? Okay. So, like I like to run. So yesterday I started running from my house. I ran to school. Okay, so I ran 5 miles, and then I walked 1 mile. Okay, so how many miles did I move? 6 miles, right? Then I ran 3 more miles. Okay, so that's 9 miles, right? Walked another mile, it's 10 miles. Ran my last mile, so 11 miles, right? So I did it in chunks, but I can add those things up and determine my total distance traveled by taking the smaller segments and adding them together, right? That's the segment addition postulate, okay? Some examples of that you're going to see. We'll do this example here together. Just to practice the postulate, to practice the concept, and this is going to be all year long. They're going to give us a rule, and then they're going to ask us to practice it with our algebra concepts that we've known from the past, okay? So if I look at this, they want to know, can you solve for x and then figure out what EF and FG are, EF and FG. So if I do this, let's say I'm starting at E, and I walk to F. What that allows me to do is say EF was my distance that I traveled. I am then going to pick up from F, and I'm going to walk to G, right? So then I added FG. What would have the total distance that I traveled, what could I call the entire distance? What is that entire segment called, that yellow segment that I highlighted? EG, right? Okay. So that's the segment addition postulate. I have now, in generic terms for this particular problem, I've figured out the 2 smaller things that need to add up to give me the total, right? And now I'm just going to go back and substitute. They're saying EF in my picture. EF is that right there, the 8x minus 14. So I'm going to write 8x minus 14. I like to put them in parentheses. You don't have to because we're just adding, but it shows me the parts, I think, a little bit better. FG is 4x plus 1. Now I have to figure out what EG is. And in my picture, if you think about it, they don't tell me anything what EG is, right? Okay, but it has to be something different than 8x minus 14 plus 4x plus 1, algebraically. Okay? Quantity-wise, they're going to be the same, but algebraically, they have to be different. Does that make sense? Or I'm going to get what we call an identity, which gives me no solution in this case, or infinite solutions in this case. Well, that's kind of what I'm getting. So if I go 12x minus 13, so you combine them, right? Okay. Now, that visually looks different, but if I combine my stuff on the left-hand side, I get 12x minus 13 as well, right? So I get 12x minus 3. I wrote 3 for some reason. Come on. All right, so this combines the 12x minus 13, and you wrote that over here as well. And I don't argue with that. That is true, okay? But it creates an equation that is trivial because subtract 12x from both sides. You get negative 13 equals negative 13, and you can't go any further, right? That's a true statement, which basically tells me what I've written as my original equation is true, but does it tell me what x was? No. So that's the problem with doing it that way. Is there another value somewhere or another expression that they give me for EG? Okay. So the EG is right there in the description, right? And I do that on purpose. I know some of us didn't recognize that right away. And I structure this every year that way because in algebra, a lot of times, if there's a picture, you guys look right at the picture and just take everything you need from the picture. Geometry, there's going to be information in the instructions. There's going to be information in the directions. So you have to read that to be able to kind of complete the entire equation. So now we get that. So this stuff on the left does combine to 12x minus 13. The right is 59. Add 13 to both sides. What's that, 72? So then x divided both sides by 12, x is 6. Okay? So last year, and pretty much every year before that, when you got x is 6, you circled it, typed it in, hit the bubble that said 6, whatever, and you're done, right? Okay? And you're going to see, let's say this was multiple choice, you're going to see option A is 6. Because a lot of people want to answer with what they found for x. Is the question asking you what x was? No. And that's different. Last year the idea was always find x. Okay? Probably 90% of the questions you did last year, find x. Okay? Now, it's find x first, but that's only a step to get towards what they're asking. So now I want to figure out what EF is. So all I'm going to do is I'm going to plug that 6 in here. So 8 times 6, and then minus 14. So what's 8 times 6? 48. Minus 14? 34. Okay. I'll plug 6 in here. Gives me, what, 25? What's 34 plus 25? 59, right? Okay. So when you're done, or when you find these values of these individual smaller distances, there should be a quick automatic check involved to make sure you got the right values there. Okay. Does that kind of make sense on how to do that? You can take the smaller values, add them together, and set them equal to the larger value. Okay, or the larger total. Now, I told you I was going to mess around with this wording of this postulate real quick. So let's do this real quick. Let's say if A, B, and C are collinear, then A, B, AB plus BC equals AC. I'm going to ask you, is that true or is that false? If A, B, and C are collinear, then AB plus BC equals AC. Is that true or false? How's that different from the original state? The original statement says if A, B, and C are collinear and B is between A and C. Did I include that betweenness statement here? No. So I'm not telling you which point is between the other two. So if I did something like this, if I went, let's just say, I do something like this. I do say A, B, and C. Would you guys agree that, okay, A to B plus B to C does equal AC? Would you say that that is true right there? But I could also, because I didn't specify, I could also have this set up. So B, A, and C there. Would you say BA plus AC? Let's ask the question, would AB plus BC equal AC? Is that true or false? So I'm going to highlight it real quick because I think it's easier to see that. Would you take that distance right there? That's BA, right? Or AB. And then BC is that purple distance. Does that yellow distance plus that purple distance equal AC, which is that green distance? No, it'd be much bigger, right? So in this case, it'd be false. So by excluding that statement of where B had to be, okay, and I'd come across the same conclusion if I would have flip-flopped A and C. Because I exclude that statement, I provide the potential for a false statement. So that's the purpose of that between statement. Does that make sense, everybody? And that's where, initially reading that, you might not think that's an important statement, but it is extremely important. Another statement that is important is the collinear part, okay? if I write it as if A, B, and C, such that let's say B is between A and C, then AB plus BC equals AC. And if I ask if that's true, if that's true or false, let's think about the pictures that we could set up there. So B is between A and C. So I could have some of my tools for some reason don't work. So let's say I have that situation there. Would you agree that AB plus BC equals AC? Is that true in that picture? That is true. Okay. But what I left out in the postulate here is the word collinear, right? So here's my question. If I leave out the word collinear, does it allow me to do this? A, B, C. Would you agree that B is still relatively between A and C? But if I go A, B, that distance there, plus BC, make my dot bigger, that distance there, would you agree that that is AC right there? Does that make sense? That's AC. That's segment A to C, right? But are they going to be equal? Is that distance AB plus BC equal to that one? No. Okay. In fact, they have to be different. That sum there has to be bigger than that side right there. Okay, by what we know about triangles. Okay, so that's not true. Okay, so what we end up with is hopefully an understanding of how, when they write a postulate for us, when our textbook writes a rule, we cannot alter that rule. We cannot change it. We cannot leave a phrase out because it might make it easier for us to remember. Because when we do that, we completely alter the meaning of that phrase. Does that make sense? And the options that are available to us. Every time an author writes something for you in a math textbook, they are trying to, mathematicians are lazy, okay? That's why we have all these notations and stuff like that, because we don't want to write things down. They are going to do things as minimal as possible. So they're not going to give you a bunch of fluff inside a phrase or something like that that you don't need, okay? So it's already bare bones as it is. So don't remove anything from that to make it even more, because when you do that, you're going to remove meaning, okay? And that can get us in trouble. Is that okay? Let's see here. Let's go down to this example. So some of your examples in Math Excel are going to have pictures with them. Some don't, okay? So this one, I should probably add the word collinear to it. So let's say A, B, and C are collinear. So B is between A and C. So I always like to draw my picture. So it doesn't tell me where A and C, which endpoints they have to be. So it doesn't matter. Okay. So if you want to flip A and C, you can. I don't think many people would do that, but it doesn't matter. It says AB's length is X. So what I like to do, I like to hide, especially if you're a person that you know you struggle with this type of thing. Get some highlighters, get some crayons, colored pencils, whatever. Highlight AB. That is one part that they're giving me. Okay. Call it X. They're giving me BC. So I highlight that. That's X plus 6. Okay. Would you guys agree that AB and BC are going to be able to be things, because they're two segments that share B, there are things that we can probably add together? And what's the total, when you start at A and walk to B and then go from B to C, the total distance you walked would have been AC, which, like you say, is 24. Okay. I like to write the generic phrase down Because once I get that down, I'm never going to be wrong, because now it's just substituting, which we worked on pretty much all year last year, right? So now you know what AB is. AB is X. I'm going to replace that thing with X. We know BC is X plus 6, so I'll replace BC with X plus 6. And you said AC is 24, so I'll replace that. Okay, so that gives me what 2x is equal to 18. X is 9. Okay. Now in this one I do ask you for X, but I also ask you for BC. So when I take X and I plug it back in to BC, what's that going to give me for BC? Plug in 9 there, it's going to give me 15. Okay. Plug in 9 there, it gives me 9. What's 15 plus 9? 24, and there's your check. That's something we can do. Okay. It doesn't really get much more difficult than that. There are a couple that talk about a midpoint, but we need to talk about this first before we talk about a midpoint. Okay. When we talk about things being equal, okay, there's confusion here with the word equality and congruence. When things are equal, that means a number is the same as another number, okay? So when you say, how old are you?
14.
How old are you? How old are you? Okay, so you two have equal ages, right? 15 and 15 are equal numbers, correct? Okay. When we compare things based on quantity, we say they're equal. When we base things based off of their shape, okay, so I might be able to take one shape and cut and paste it and lay it on top of another shape, and that happens and that works. There was some distance equality there, right? But when a shape lands on top of another shape, we call that congruency, okay? So it says in geometry, when two or more objects have the same size and shape, they are said to be congruent, okay? So for instance, like if I have a rectangle and a triangle, they might both have the same area, so there's a quantity that is equal, right? But a rectangle will never lay exactly on top of a triangle or vice versa, so we wouldn't say they're congruent. Does that make sense? So there might be quantities that are equal from shape to shape, but they might not be congruent shapes. They have to be the exact same shape, and they have to have the exact same size, okay? So when I look at this shape down here, congruent segments, all that means is that they're two segments that have the same length, and because they're both segments, that means they're the same shape already, so they're congruent. Does that make sense? Okay. And it just means when we talk about congruency, we're just thinking, can I take this image here, cut and paste it out, and it lay directly on top of that one? Okay. Now you might have to rotate and stuff like that, and that's fine. Okay. But when I want to talk about these two shapes being congruent, I think I might have this in the next. Yeah. In the next slide, says if I want to talk about them being equal length, then I say AM's distance is equal to TZ's distance. Even if I didn't know exactly what their distances were, but I was able to visually put them on top of one another, I'm going to say the length attached to AM is equal to the length that's attached to TZ. Does that make sense? Okay. So I have to do it without the symbols on top of the letters. If I want to tell people that these two shapes are congruent, so that I can cut and paste them, I would say segment AM. And then we write our congruent symbol, which is that symbol there, an equal sign with that little tilde on top. And then I say segment TZ. Okay. Sometimes, and it's especially if you get into like higher level mathematics, like writing that tilde, for some reason, mathematicians have said that's too hard to do. Okay. Even with some typesets on like computers and stuff like that, it's hard to find, it's hard to use. So sometimes they just use 3, like an equation or an equal sign with an extra line above it. But those all mean AM is congruent to TZ, meaning the segment can be cut and pasted on top of the other one. that all right? If I have two segments that I know are congruent, I automatically know their lengths are equal. If I have two segments that I know they have equal lengths, then by definition, I know they're congruent because they meet the fact of having both being the same shape and both having the same length. So now that we know what congruency means, we can talk about midpoint. Okay, a midpoint is exactly what it says. Mid means middle, right? Point means point. It's the point in the middle. Okay, it's a point that divides a segment into two congruent segments. It's the point that divides a segment into two congruent segments. Only segments have midpoints. Okay, when we start talking about circles, eventually arcs will have midpoints. But things that we know so far, lines and rays, they don't have endpoint, or they don't have endpoints, so they cannot have midpoints. Does that make sense? So what I like to think about is like a shoestring. If I have a shoestring, and you guys have all done this when lacing your shoes, do I take I forget what those, you guys know what those metal things are called? I forget whatever those metal things are called, or plastic things on your shoestrings, you put those together, right? And then you put, what would you say? Anglets. Okay. You sure? All right. Okay. So you put those together, and then you fold your shoestring in half, and you've got the midpoint then in your other hand, right? Does that make sense? Okay. So all segments you can do that. Think about a line. A line goes on forever, right? So if a line were a shoestring that goes on forever, can you ever put your hands on those plastic things? No. So you can never put them together to find the midpoint, right? So lines don't have midpoints. Same thing with rays. Rays don't have midpoints. Okay. Only segments have midpoints. Okay. A bisector. Okay. So sector refers to section. And what's the prefix bi mean? Two. Okay. So a bisector of a segment is something that is going to cut your segment into two parts. Now, there's a mathematical component to this as well. Because just tearing that apart with knowing what bi and sector means doesn't lay out everything we know about a bisector. It has to pass, for our geometry, that object has to go through a midpoint. Okay, so if I'm in, let's just go to GeoGebra here real quick. If I give you a segment and ask for the midpoint of that segment, so there's the midpoint, okay? Anything that I draw through C, so maybe it's a line. So that line right there, let's color it red. So that red line would be a segment bisector because it goes through the midpoint of AB. Does that make sense? Okay. And I can guarantee to you, it's out to 15 decimal places for some reason. If I look at that distance compared to that distance, would that tell you right there that AC and CB are congruent? Okay. So that line would be a segment bisector. So any one of these lines would be. Okay. If I make it a ray, so I go that direction, let's get rid of the line then. Okay. Does that ray still intersect and make two congruent segments? So that's a bisector. Even if my ray started kind of like this, let's get rid of that one. Okay. Now that ray is starting over here. Okay. Was it still passing through C? Yeah. Okay. You can have another segment pass. You can actually have another plane that passes there. So it's hard for me to draw the plane. Maybe I'll do that tomorrow for you. But essentially any shape that we are familiar with yet that goes through the center point or the midpoint of a segment is referred to as a bisector of a segment. Okay. So why are we talking about that? We're going to get questions that look like, we'll scroll all the way down here to this one. It says W is the midpoint of XY. find the length of WY. Okay? So what a lot of people do, and this is going to happen in your homework. In your homework, there might be like 10 questions of segment addition. And so that those 10 questions train you on what to do, and you almost become robotic. Like question 8, 9, and 10, you're like, I've done this. This is easy. This is easy. I got this is cake, right? And you just zip through them. And then the 11th question throws a wrench into it, and it says something like this. But you see the picture, and you say, I'm going to take A plus 11 plus 2A minus 5. Because you've been doing segment addition for so long, right? You've seen so many examples of it. So you're going to say A plus 11 plus 2A minus 5 equals, and then you're going to be looking for what does it equal? Well, it should equal XY, right? You've taken XW plus WY. It should equal XY. But is there anywhere up there that it tells me what XY is? No. Okay? It's not wrong. That's a true relationship between the components or the parts that are up there. But I don't have enough information to finish it that way. And this is where we've got to pay attention to the directions. What does it say about W? It's a midpoint, right? So what does that tell me about that segment there compared to that segment there? They're equal, right? XW's length should be the same as WY's length. So doesn't that mean that A plus 11 is equal to 2A minus 5? Does that make sense? And that's an equation. It's not that, once you got the idea, it's not that difficult to set up and solve. But if you're not paying attention to the vocabulary and the instructions, you're going to overlook it. So now I'll subtract A from both sides, add 5 to both sides, so we get A to be 16. And again, there's built-in checks to this stuff. If A is 16, what's that quantity? What's 16 plus 11? 27. What's 2 times 16? 32 minus 5? 27. Are those two numbers the same? Does that prove to you that W was a midpoint? Okay. Any other number other than 16 would not show that. It'd show that W is closer to X or closer to Y. That kind of make sense? Okay. When I make these notes, guys, these PowerPoints, and you saw we skipped over a couple, I've always made my notes for all my classes more than what we're going to be able to cover in class, okay, in regards to examples. So if there's extra examples that we skip over, those are for you to do on your own time if you want. Okay, I would suggest to do them. And if you ever need like verification or reassurance that you're doing them correctly, just let me know, ask me, and I can take a look at them. This evening, 1.3 will be open. Okay, I'll open that here in a moment. And that will be due not tomorrow, but Wednesday. Okay, 1.2 is due tomorrow, and you need your password changed.